Hi. So far we have discussed Laplace transforms and also inverse Laplace transforms and the various techniques to find these transforms. So now we will go into the applications of using these Laplace transforms to find the solution of ordinary differential equations. Okay, so before we use them in applications, we should know how to find the Laplace transform of derivatives and integrals, because in the ordinary differential equations you know that it will contain derivatives, and also in order to find solution you need to find integrals also. So you should know how to find the transforms of derivatives and integrals of the functions. Okay, so this lecture is very essential for you to solve the problems involving ordinary differential equations. So first of all we will be discussing how to find the Laplace transform of derivatives and also integrals. Okay, so as I told you, Laplace transform method is method of solving ordinary differential equations and initial value problems. Okay, and when you solve ordinary differential equations, you will understand that the operations of Laplace transform is just like doing operations on algebra itself. So when you do those problems, you will understand it better. Okay, so as a thumb rule, I'll say that finding Laplace transform of derivatives like just multiplication. Okay, so we'll come to that now, and also finding Laplace transform of integral is like division. Okay, it's just a like a reverse process like this. So we'll be discussing both these concepts now. So first of all, we'll discuss how to do. What do you mean by Laplace transform of derivative? Okay, so that's the first concept which we'll be doing now. Okay, so before that, suppose I'll give some preliminary things here. So suppose we have function y. Okay, suppose the Laplace transform y is written as L of y. Okay, now we'll discuss what is the Laplace transform of L of y dash. Okay, similarly we'll discuss what is the Laplace transform of y double dash. Okay, so you have, suppose we have function of y. Suppose the Laplace transform of y is L of y. We will discuss how to write the Laplace transform of y dash and y double dash in terms of this y and L of y. Okay, so it is very simple thing. So first I'll write a pattern here. The Laplace transform of y dash is nothing but is s into L of y minus y of 0. Okay, I'll write once again. Laplace transform of y double dash is nothing but s square into L of y minus s into y of 0 minus y dash of 0. Okay, I'll write one more thing, then we'll generalize it. Laplace transform of y triple dash is nothing but s cube into L of y minus s square into y of 0 minus s into y dash of 0 minus y double dash of 0. So you can see that Laplace transform of any order. Okay, so here the number of terms, number of s's will be depending upon the order of the derivative. So suppose you are taking L of y dash, you will have to bring one s here. Suppose you are taking L of y double dash, you have to bring 2s here. And similarly, if you are taking y triple dash, you have to bring 3s here. Okay, so and at each successive steps your s will be reducing. Okay, so in the first step you had s into L of y. In the next step there will not be s, so 1x will be reduced, you will get y of 0. Okay, in this case what happens, in the first step you had s square into L of y. In the next step you have to reduce this s, so it is simply s. So when you reduce s, you have to bring this y of 0. Okay, so again reduces minus y dash of 0. So there is no more s to reduce, so that is the end point here. Okay, similarly let us try what is L of y triple dash. How will you write it? So you have to write the as many as the order of the derivative here. Okay, so you have to write s cube, okay, into L of y minus, you have to reduce s in each step and increase derivative at each step. So here you will have minus s square into y of 0. Okay, again 2s are there, so I'll again take the next step as minus s into, you have to increase derivative here, y dash of 0. Okay, again you can reduce an s here, minus y double dash of 0. Again there is nothing to reduce here, so we'll stop it here. Okay, so if you have understood this, how to write, there is no need to start derivation, you have to just know how to write this term here. So if you have understood this, let us try to write what is y raised to 4. Okay, L of y, the fourth derivative. What is it? It's simply s raised to 4. Depending upon the order, that means s will be there. S raised to 4 into L of y minus s cube into y of 0. Okay, now decrease s and simultaneously increase the derivative of y also. So it is, next step would be simply minus s square into y dash of 0 minus s into y double dash of 0 minus y triple dash of 0. So this is how you write the derivatives. Okay, so I'll write the formula here once again. So this is the formula. L of f raised to n is nothing but s raised to n into L of f. Again, next step you have to reduce this s. So minus s raised to n minus 1. You will start with f of 0. At each successive step, you will be reducing s and increasing derivative of f. Okay, so in the next step it will be s raised to n minus 2 into f dash of 0. Again, s raised to n minus 3 into f double dash of 0, etc. etc. You have to go till all the s's are exhausted. So that is the formula. So I hope it is clear. Usually in the problems we will have to deal with L of f dash and f double dash only. Maximum we will have f dash and f double dash, or y dash and y double dash. Maximum only these many things will be there. So I'll write the formula for them explicitly now. So L of f dash is nothing but s into L of f minus f of 0. As I told you, L of y dash is nothing but s into L of y minus y of 0. And similarly, what will be L of y double dash? L of y double dash or L of f double dash is something s square into L of f minus s into f of 0 minus f dash of 0. Okay, so please try to write down these formulas by yourself, because you will be using these two formulas extensively. Okay, so similarly you can write the Laplace transform, the derivative formula for higher orders also. Maximum you will only be needing f dash and f double dash, or y dash and y double dash. Okay, that is only much that much is required for it. Okay, so even for L of f double dash also I have given to you here. It is nothing but s cube into L of f minus, you have to reduce as s square and f of 0, again reduces and increase the derivative of f, that is minus s into f dash of 0 minus f double dash of 0. Okay, so you can see that taking derivatives involves actually by multiplying the function by taking derivative of some f involves multiplying the transform of f by this s. So the transform of derivative actually involves multiplication by s. That is one observation which we will make here, because the reverse process of differentiation, which is integration, will involve division by s. Okay, so we can connect both of these concepts when you study integration also. Okay, now let us try to do some problems here regarding with this integration differentiation. As you say, let us try to find the Laplace transform of f of t is equal to t sine at using differentiation technique. Okay, so let me tell you once again, the differentiation formula is basically used for solving ordinary differential equations only. It is not directly used to find transforms. Okay, because it is very difficult to use the differentiation formula to find the transform. Usually we don't use those methods. We will be applying other methods only. But for what you say, having say an interaction with this formula, let us try to do this problem using differentiation. Okay, so as I told you, you don't use derivative formula for finding transforms directly. You will be using other methods. Even for t sine at we have done earlier also. How will you find the transform of t sine at? You will write sine at as e raised to I at minus e raised to minus I at by 2i. So when you multiply this with this, and then you will use the shifting theorem, and you can find the transforms in that method. So that is the easiest method there. But still I will be using differentiation method also, but never use differentiation methods in problems, because it will be a bit tougher if you really don't understand how to use it. Okay, so usually we employ the differentiation formula only in solving ordinary differential equations, which we will be doing in the next session. Okay, in that case you will be using the formula, but for directly you will not be using it here. Okay, so let us try to do it here. So in these type of problems, what we will do is that we will take f of t here, and you will try to take the derivative of dash of t. Okay, so suppose you don't know directly the transform of this, so what you will do is that you will try to find f dash of t. Suppose you know the transform of f dash of t, suppose you know the transform of f of dash of t, suppose it is something like that. From that you can read out the transform of f of t by using the formula of L of f dash of t. Okay, that is the idea here. Okay, so sometimes you will have f of t directly, you don't know the transform of that. So in that case, what you do, you will take f dash of t and look whether it's a known function whose transform could be found out easily. Okay, so if such a case is there, we can easily read out the original function from the formula of derivatives. Okay, I'll show it here. We'll discuss that also. Okay, suppose you don't know the transform of f dash t, you will again go to f double dash of t. Okay, again you look whether f double dash t is a known function. So using that known function, you will write the transform of that, and from that you are writing the formula of derivatives, you can find the original transform. Okay, so that is the idea which you are going to employ here. So it is not a usual idea, that's why I told don't use this directly for problems, use the other methods, but let us try to do it now here. Okay, so suppose my f of t is t sine at, I don't know transform directly, so I'll try to find f dash of t. So what is f dash of t? Take derivative of f dash f of t, it is nothing but first function t into cos at into a, right? Okay, plus sine at. Okay, and also I can see that I know the transform of sine at, but I don't know the transform of sine at into cos at, t into cos at. So I can't use the formula there. Okay, so moving forward, I'll try to find f double dash of t. What is f double dash of t? Again, if you take derivative, it is nothing but a cos at is there. Okay, then minus a t sine at, sorry, a square t sine at is there. plus a cos at is there. Or in other words, I can write this as 2a cos at minus a square t sin at. Okay, so you are getting your f double dash of t like this. Okay, so in this step, if you can see, if you notice this, you know this, the transform of cos at here, you know the transform of that. But you can, if you look at this second term here, it is actually a known term. Okay, because a square t sin at, this t sin at is actually your f of t. This is, if you notice that your t sin is 80 is actually f of t. That is, your f double dash of t could be written as 2a into cos at minus a square into f of t. You can write it like that. I hope it is clear. Okay, now let us apply. So when you have reached this stage, so you know already you need to find L of f of t. So suppose I need to find L of f of t. So what I'll do is that I'll take the transform on both sides. Okay, so I'll take the transform on both sides. What is it? So now I have got your f double dash of t as 2 cos 8 into a square f of t. Now I'm going to take the transform both sides. What will I get? It is simply L of f double dash of t. Okay, that is equal to transform this one is, you applying linearity, you will have 2a into s by s square plus a square minus a square into L of f of t. That is your RHS. And your LHS is L of f double dash of t. It can be written as, using the formula, it is s square into L of f of t minus s into f of 0 minus f dash of 0. Okay, so this much you will get. Okay, now I can take this L of f t together. Okay, so what will I get? So I will have, when I take this L of f t together, what will I get? It will be simply L of f t into s square plus a square in your LHS minus, what is your f of 0? Your f of t is actually t sin 80. So what is your f of 0? F of 0 will be simply be 0. Okay, and similarly f dash of t is this. So what is f dash of 0? Again, f dash of 0 will be sin a 0, it is 0, plus a into 0, that will be 0. So both these terms will be 0 simply. So you'll be getting this as s square plus a square is equal to L of f of t into s square plus a square, which is equal to 2as by s square plus a square. Or in other words, your L of f of t is simply 2as by s square plus a square whole square. Okay, so this is how you are employing the differentiation methods to find the transform. So it is not a usual method, don't use it if it is possible. So in this way also you can do. So the idea is, you take f of t, then you take f dash of t. If it is a known function, apply the differentiation formula there. If it is not a known function, go to again f double dash of t. Again, if it is a known function, apply differentiation formula. Or if you get the original function in that stage also, you can apply differential formula, and you can then take the L of f t to your LHS and group all over terms of your RHS and find the answer. So that is another method. Okay, so if you have understood this method, you can also try to find the transform of t cos 80. Okay, so using differentiation methods, try to find the transform of t cos 80. You can also use other methods also. Okay, so as I told you, you have to study only differentiation formulas from this section, and the main use of differentiation formula is, while trying to solve ordinary differential equation, you will need to apply this differential formula, which we will be using in next session. But for directly finding transforms, we never use this formula. But still, if you want, you can use this method also. I'll also try to do one more problem for you. Okay, so this is the method which I have elaborated here. Okay, so let us do some other problems also is here. So suppose you need to find the transform of t raised to minus 80. T raised to minus 80. Okay, already you know some method to find it. Using the shifting theorem you can do it, but still let me try to establish this one here. So if you want to find, suppose I need to find it, I'll write f dash of t. What is f dash of t? F dash of t is nothing but e raised to minus 80 minus t e raised to minus at into a, right, plus t e raised to minus 8 into minus a, or you will get this as e raised to minus at minus a into f of t. Okay, so in the second stage you are getting back the original function, so you apply the Laplace transform here itself. So you will be getting this L of f of dash of t. L of f of dash of t is, which is equal to s into L of f, right, f of t, s into L of f of t minus f dash of 0, sorry, s into L of f dash of t minus f dash of 0, which is equal to e transform of e raised to minus 80 is 1 by s plus a minus a into L of f of t here. Okay, bring L of f of t to one side, so we'll be getting this as s plus a into L of f of t is there, minus what is f dash of 0? what is f, sorry, it is not f dash of 0, it's simply f of 0 here. So please make this correction here. So what is f of 0? Your f of 0 is actually 0 because your t is 0. So we'll be getting 0 there, which is equal to 1 by s plus a, or your L of f of t is nothing but 1 by s plus a the whole square. Okay, you can also find the transform of t e raised to minus at using the shifting theorem. So in that case, your transform of t is 1 by s square, but because of the factor of e raised to minus 8, it will become s plus a, that is s plus a the whole square. Okay, so that method also you can find it out. Okay, so using those methods also you can find it out. Okay, so don't use this method if don't use the differentiation method if you can find using other methods, because that is much easier. Okay, so these problems also you can try it out. So I'll suggest you don't want to do those patterns using differentiation. You can use other methods, but still you can try these problems here. Especially try to find the transform of sine raised to 4t here. Please try to find it out using differentiation methods. I'll give an assignment also. If you don't find it, I'll explain it later on in the video. Okay, so please try to do that also. Okay, so let us move forward. Now let us try to find the integration, the Laplace transform integration. Okay, the idea is very simple here. In the Laplace transform integration, it's very simple. Suppose we have f of t here. Okay, suppose its transform of is f of s. Okay, so I told you the transform of a derivative f dash of t would contain this s into f of s, or plus some constants would be there. Okay, so transform the derivative would contain some multiplication. Okay, but what happens when you have to find differentiation here? Okay, so when you take integral, what happens is actually you will be getting the transform as f of s by s. So that is the idea here. Or in other words, I am telling you formally, suppose your f of t has transform f of s, then your f of s by s has inverse transform integral 0 to t f of t dt. So this is the result here. Okay, this is the method which we'll be using here. This is basically used for, this is extensive, this formula is extensively used to find inverse Laplace transforms. Okay, so we'll be using many problems, many methods here. So this formula is very important. Okay, so the formula is this. I'm rephrasing in terms of Laplace inverse Laplace transform, that is the inverse Laplace transform of f of s by s is actually integral 0 to t the integral of f of t dt, where this f of t is actually the inverse transform of this f of s. Okay, for example, suppose I'll illustrate the examples once I give the correct formula here. Okay, so this is the formula to you. The inverse transform of this, so suppose you have your f of t has Laplace transform of f of s. Okay, that is inverse of your f of s is f of t. Then inverse of f of s by s is nothing but integral 0 to t f of t dt. This is the formula. Okay, so as you can see that this is exactly not correct in mathematical terms, because already I am using the variable of integration as this t here, that's not correct here. But for simplicity, you can use this method itself, because essentially the idea is same. Okay, in the formulas I have used another variable because the limits and the variables should be different here. So I have used a variable tau d tau here. It's not necessary. This is only for mathematical correctness I have used here. But in problems you can use this formula itself. Okay, so inverse transform of f of s by s is nothing but integral 0 to t f of t dt. Okay, this formula is very important. It will greatly help you to solve problems involving finding inverse Laplace transform, especially in solution of ordinary differential equations. So let us try to do many problems regarding this integration here. Okay, so the idea is, when you are given a function, if you are asked to find the inverse Laplace transform, the idea is first we have to identify this f of s. Okay, so the f of s should be identified in such a way that its transform could be easily found out using the table of Laplace transforms. Okay, so if you have identified f of s, you can easily find the inverse transform of f of s by s by integrating this f of t dt. So there are two steps. First, you have to identify f of s and use that to find the inverse Laplace transform using this formula. Okay, so let us try to do some problems. We'll be doing many problems, so that this is much more easy for you to understand. So you please try to do these problems with me. Okay, so let us try this problem. So let us find the inverse transform of 1 by s into s square plus a square. Okay, so I hope you know one method. You can use the partial fractions method to solve this problem also, but I will try to use the integration method here. Okay, so for integration, you have to look at the term of the form f of s by s. Okay, so if you look at that one, what is your f of s here? Your f of s is actually 1 by s square plus a square. Okay, so you know inverse transform of 1 by s square plus a square. It is nothing but 1 by a sine at. Okay, this is your inverse transform. Okay, so now what will be the inverse transform of f of s by s, or your 1 by s into s square plus a square? What will it be? It is nothing but, according to the formula, it will be simply be integral 0 to t f of t dt. Okay, integral 0 to t f of t dt, that is nothing but integral 0 to t 1 by a sine a t dt. Okay, I hope you understand how to write this. The inverse transform of f of s by s is nothing but integral 0 to t f of t dt. Using that method I have written here. Okay, now you can easily integrate it. What's the value of this one? So it is actually integral 0 to t 1 by a sine a t dt. What's the integral here? It is 1 by a into integral of sine a t is cos minus cos a t in the limits 0 to t. So what will you get? You will be getting this as 1 by a into 1 minus cos 80. So this is your inverse transform. Okay, so 1 by a into 1 minus cos 80. Okay, so not 1 by a, so inverse transform, so it is cos 80 by a is here, so it will be 1 by a square into 1 minus cos 80. Okay, so this is how you find the inverse transform of 1 by s into s square plus s square. Okay, you can see it here. Okay, so if you have understood this, can you tell me now, suppose now you know the inverse transform of this, nothing but 1 minus cos at by a square. Okay, now can you find the inverse transform of 1 by s square into s square plus a square? What will it be? So it is nothing but you take the inverse transform of this, you already know it, then you have to integrate it from 0 to t dt. You will be getting the inverse transform of 1 by s square into s square plus a square. So I hope you can do that also. So what is it? Simply it will become 1 by a square into t minus sine a t by a in the limit 0 to t. So it is when you apply this thing, it will be simply be 1 by a square into t minus sine a t by a. When you apply lower limit, it will be simply 0. So this is the inverse transform here. Okay, so we can do that also. Okay, so I hope it is clear how to use integration to find the inverse Laplace transforms. Now let us do some more problems with this regardless. So remember, suppose your f of s has inverse transform of f of t, then your f of s by s has inverse transform of integral 0 to t f of t dt. Always remember this result. Now let us try to do some problems here. So what is the inverse transform of 3 by s square plus s by 4? What is the inverse transform of that? Okay, so you can also use other methods also, but let me try to use integration. Now this is actually can write it as 3 by s into s plus 1 by 4. Okay, now can you identify your f of s? Your f of s is nothing but 3 by s plus 1 by 4. What is the inverse transform of that? It is nothing but, like if you look at the table, it's a transform of e raised to at, so it is nothing but 3 e raised to minus 1 by 4 t. Okay, so 3 e raised to minus 1 by 4t. So the inverse transform of this would be simply be integral 0 to t 3 e raised to minus 1 by 4t dt. So please find it out. It is nothing but 3 into e raised to minus 1 by 4t by minus 1 by 4 in the limits 0 to t. So what is it? It is 3 into 1 minus e raised to minus 1 by 4t in minus 4 1 minus 1 by 4t. Okay, so using the upper and lower limits, you can easily find it out. Okay, so when you apply 0, so it is simply actually 4 minus 4 into e raised to minus 1 by 4t. Okay, so that is it. Okay, so please find it down that also. So it's actually 12 into 1 minus e raised to minus 1 by 4t. Okay, so using the same method, can you find the inverse transform of this one? Okay, so this can be written as actually 20 by s square into s minus 2 pi. Okay, so in order to find the inverse transform of this, first you find the inverse transform of 20 by s into s minus 2 pi. Okay, before that find the inverse transform of 20 by s minus 2 pi. Okay, once you find the inverse transform of this one, that is simply 20 e raised to 2 pi t. Okay, you can find the inverse transform of this by simply integrating this from 0 to t dt. So what is it? Simply 20 e raised to 2 pi t into 20 e raised to 2 pi t by 2 pi in the limits 0 to t, that is actually but 20. So it is simply 10 e raised to 2 pi t minus 10 by pi. Okay, so 10 e raised to 2 pi t minus 10 by pi. Okay, so once you have found the inverse transform of this, you can find the inverse transform of this by again integrating this from 0 to t dt. Okay, I hope this is also clear. Okay, so please do that. Simple integration. Okay, so moving forward, can you find the inverse transform of 1 by s raised to 4 minus s square? How will you do that? First, you find the inverse transform of 1 by s square into s square minus 1. Okay, before that, find the inverse transform of 1 by s into s square minus 1. Before that, find the inverse transform of 1 by s square minus 1. What's the inverse transform of 1 by s square minus 1? It is nothing but sine ht. The inverse transform of 1 by s square minus 1 is sine ht. So now if you integrate it from 0 to t dt, you will be getting the inverse transform of this one. And if you integrate the result of that also, you will be getting the inverse transform of this one also. Okay, I hope that is also clear. Okay, moving forward, this question also you can do it now. S plus 1 by s raised to 4 plus 9s square, how will you do it? So I can write this as s plus 1 by s raised to 4 plus 9s square. If I take s square outside, it's simply s plus 1 by s square into s square plus 9. Okay, so before finding the inverse transform of this, find the inverse transform of s plus 1 by s into s square plus 9. So before that, find the inverse transform of s plus 1 by s square plus 9. That already you know. What is it? It's nothing but it is cos 3t plus 1 by 3 sine 3t. Okay, so if you integrate it from 0 to t dt, you will be getting the inverse transform of this one. Okay, again if you integrate the result again with respect to 1, so from 0 to t, you will be getting the answer of this also. So it's all straightforward calculation. So using the integration, you can easily find the transform of these functions also. Okay, so again moving forward, I hope you can just do this one also. Take s square outside, identify f of s. Okay, you can also do these problems also here. Okay, so that is the way of integration, method of integration to use the Laplace transform. Okay, okay, and one more property is the change of scale property. Since this is not mentioned in the syllabus, it is not required for exam, but still I am just mentioning you the result also. It's not required for you, but still it will be interesting to note that the Laplace. So if you have f of, suppose you have the transform f of t is f of s. Okay, you know the transform of c into f of t. It is simply c into f of s using linearity property. So what is the transform of f of ct? Okay, the transform of f of ct is nothing but 1 by c into f of s by c. So this is the change of scale property. So don't confuse it with c into f of t. This is linear function. Here you're actually the variable inside your f is multiplied by c. Okay, so the transform of L of f of ct is nothing but 1 by c into f of s by c. It is not required for examination, so I'm just telling you for information only. So that is also is one result, is an interesting result. We'll not be using this result, but I have also included one problem for your understanding. So if you want, you can do this problem also. It is given to you that the transform of this is this one, and they have asked you to find the transform of this one. Okay, so if you look at this result, transform of f of some constant t is 1 by that constant f of s by c. So you know this one, you can see the difference between these two functions is you have changed t with 2t here. So what's the transform of this one? That simply be 1 by 2, that's 1 by c into, you will have 2 by, instead of s you will have s by c. So it will be s by 2 plus 1 into s by 2 the whole square plus 2s by 2 plus 5. Okay, so that's one interesting result involving change of scale. It's not required for you. The only thing which is required is you should know how to write the differentiation formulas. That's very important. Okay, and also you should know how to find inverse transform using integrals. So only these two results will be using extensively. You will not be using differentiation formula to find transforms. You should know how to write differentiation formula. Okay, that is actually used for converting your ordinary differential equation. That you should know, and also you should know how to find inverse transform using integrals. So these two things should be clear from this discussion. Okay, so that's it. Okay, so thank you.